Okay, so we need to talk about interaction models from Thinking Machine because they are genuinely impressive, and I think they have the possibility of really changing the way we interact with computers. I unfortunately haven't seen much coverage on YouTube, so I thought to create this video. My focus is going to be more on the technical details because that what is interesting to me. But there are some pretty interesting demos that I'm going to show you in this video. But first, let's address the elephant in the room. Some people are comparing this with the GPT-4o that was released by OpenAI a couple of years ago. Now we have a second version of that. But I think the technology that Thinking Machine is using is very different. The way they have trained a unified model that can tokenize time is a very different approach than what things like GPT-4o's advanced voice mode or even things like Gemini uses. And that's what I want to focus in this video. By the way, this person that you see here in the GPT-4o demo is the same person that is showing the interaction model demo in Thinking Machine. Most of the team is coming from either DeepMind, OpenAI, or I think there are a couple of people from Anthropic, but these are the people who have worked on similar systems in the past, and they are building the next version of these. Okay, so I find this demo pretty interesting, so let's watch it, but it also shows you the capabilities of this model as well.
You're going to translate what I say into HR speech, okay?
Exactly. I'll be reframing everything you say into uplifting professional language instantly.
Hi, Alex. I cannot stand your lateness.
Hi,
Every
Alex.
day, you show
We'd
up
love
after
to explore
lunch and
opportunities
skip
to enhance
every
your
morning
timeliness and
meeting.
morning engagement.
You cannot expect the rest of us to rearrange our workflow
Let's
around
collaborate on a schedule that ensures
makes you
everyone
look like
stays
a
aligned
slob.
and included in those
Other
key
Okay, so a couple of things to notice here. First of all, the model is interacting with the user in real time. And as the user is talking, the model is able to not only produce responses, but it's also able to keep track of what the user is saying, right? So it's not a multi-turn conversation where in the first turn the user asks something, the model responds, then the user asks something subsequent, the model is going to respond again. But this is very different. And let me explain how this works. But before that, let's look at what a usual full duplex voice-to-voice agentic system looks like. Now, usually people combine multiple different components together to create these interactive systems that feel like real-time responses from the single model. But in fact, there are multiple different components. So in a traditional system, you would have a voice activity detection, which detects whenever a user is speaking or they start speaking, right? Then you have a speech to text model that is going to convert your speech into text that is sent to the LLM, which is basically the brain of the system. And then you have a text to speech component. And on top of it is session management or orchestrator layer. And then there is going to be external services, which basically keeps track of when the user starts talking, right? So normally there are a lot of different moving parts, okay? And that's what enables voice multi-turn conversational systems. So a simple view would be the human has an input, the model produces an output, there's a second input, the model produces another output, right? And if you think about it in this voice-to-voice system, you're talking about input to the whole system generating an output, right? Thinking Machine took this to a next level, in which they tokenized time itself. So they have time-aligned micro-turn. Now, let me explain this by playing this. So they are keeping track of text, audio, and video simultaneously. Everything is tokenized into 200 millisecond chunks, and those chunks are going into the system. Now, they're calling these micro-turns. So the system actually keeps track that every 200 milliseconds if there is something said by the user that it needs to respond to. And it's able to keep track of the conversation history and simultaneously is able to generate outputs as well. So not only it's tracking inputs, but it also doing internal state management and response generation. Now, this 200 millisecond makes it almost real time. So what are the different capabilities that this type of time tokenization enables, right? So some of the capabilities are seamless dialogue management, Now, here's one quick example.
I'm gonna tell you a story, and whenever you hear an animal word, please count the number immediately.
Gotcha. I'll count them out as you go. Let's hear it.
Okay, last weekend, I drove down to South Bay to visit a farm.
Okay, so now this is the most important part, right? Since it's doing this macro turns, all right, it's able to keep track of the user intent. So in this case, it's expecting that the user is going to continue this conversation, and that's why it's not responding.
On the way there, I saw a deer.
1,
And when we got to the farm, we watched a demonstration of sheep shearing.
2,
Then on the way back, we
Right, so it has this internal capability to manage the state of conversation. Now, this is multimodal, and it can do verbal and visual interjections. So this was actually a funny demo.
Okay, I'm doing some work. Let me know if I start to slouch.
I've got you. Sit up straight and you'll be golden.
All right, so
You're starting to slouch forward. Try pulling your shoulders back. Much better. You're
the
upright
video
again.
and
Like that can
verbal
strain your neck.
interjections.
Try keeping it.
Now, one thing they highlight is time awareness, right? So if you ask advanced voice mode in ChatGPT to keep track of time, it's not able to do it. It has to use an external tool, but since we said that they're tokenizing time itself, so it can measure how many tokens have passed, and then it can actually tell you how much time have passed. Okay, so this is a block diagram of the overall system. There are two different components. One is the interaction model. This is the real-time model that interacts with the user, and it's extremely fast. But it's not the smartest model. It's actually only 276 billion parameter model, which is relatively small. However, they created this whole architecture where it can offload tasks to a background model which is running asynchronously and which is much more capable. So if the model is interacting with the user in real time and it needs some more reasoning intensive or knowledge intensive tasks, it can just offload it to this background model, which is a lot more capable. It has access to a lot more tools that is going to perform all the operations asynchronously, and then feed that response back into your interaction model, and it can generate responses. Now you can think about this, and it's basically hand off to a more capable model or routing. And you can use the same concepts in building agentic systems. Now, in order to support this, they had to really rethink what type of infrastructure they will need. And that's, I think, one of the most impressive thing about this release. They had to completely redesign the whole infrastructure around the model, not just the training, but how they would do inference. This is encoder-free early fusion, right? So rather than processing audio and video through a large standalone encoders, we opt for a system with minimal pre-processing. One thing which I really like about this blog post, which essentially is a technical research paper, they have highlighted previous work in the domain, and especially this is built on top of some of the open source work. Especially they highlight models like Mushi from Qtai. So it's actually a genuinely pleasant paper to read. So in terms of architecture, they're taking the text, tokenizing the text, generating embeddings. Then for videos and images, they're taking 40 by 40 patches, passing on to MLP layer. And for audio, they are computing multispectrum features and then creating a bag of embeddings. Everything is passed on to a transformer layer. And this is tokenized into that 200 millisecond token windows, right? So that's basically the time tokenization. Now for inference, they say that at inference time, 200 millisecond chunks require frequent prefill and decode of small sizes, each having to meet strict latency requirements. So they say that existing LLM inference libraries are not optimized for frequent small prefills. They often have a significant amount of overhead per turn. To address this, we implemented streaming sessions. So this is a new innovation that they had to do in order to optimize the inference. Otherwise, it would be way too slow. Now, the model that they are showcasing, they haven't released the model. It's not available through an API yet. They are calling it TML interaction small. And as I said, this is a 276 billion parameter MOE or mixture of expert. This is very different than other frontier labs because they usually don't share information about the size of the model. But here it's a 276 parameter mixture of expert with 12 billion active parameters. Now, compared to some of the other models like DeepSeek V3, which was, I think, 600 parameter models, it's relatively small. However, if you look at some of the real-time interaction or Omni models in the open source space, like Mushi from Qt or even the Quinn Omni, this is a relatively big model. And it's kind of funny that 276 billion parameter model is a small model according to Thinking Machine, which shows you that the frontier models that we are seeing, there are orders of magnitude bigger, and kind of give you a clue because these people have been working at all the frontier labs. Okay, I want to show you one more example before we look at some of the benchmarks. So this is an interesting example where she's going to show her hands and then the model is supposed to count. So let's have a listen.
Hey, watch my hand and give a running number of my fingers. Give me an update whenever I make a change.
Got it. I'll keep track. 5 fingers up. 2 fingers up. 10 fingers up. 9 fingers up.
Okay, again, since it's tokenized time, it's able to basically look at this live stream almost real time. Now, these other models like Gemini or even real-time GPT, they basically take images at certain interval. So if you look at something like GPT real-time high, let's have a listen.
All right. I'll keep an eye on your hand and count out loud whenever your fingers change. I can't see your fingers right now, so the visible count is 0. Bring your hand into the frame, and I'll call out the number each time it changes.
All right, so it seems like it's completely missed because probably the interval it's using to take sample somehow misses the hands or it's not able to recognize it, right? Let's have a listen to Gemini as well.
I can see your hand yet. Let me know when you're ready to start.
All right, same issue. And if you look at the other demos, you're going to see similar issues. Okay, so that brings us to the benchmarks. Now, there's only one benchmark that actually measures true interaction. These other benchmarks don't really measure true interactivity between the models. But overall, I think it's a pretty impressive model. But when the model is released, then we're going to see how good this model is in real world scenarios. Here's a plot which measures intelligence versus interaction quality. So this TML small scores really high both on the interaction axis as well as on the intelligence axis. And then here's another one which is intelligence versus responsiveness. Again, it seems to be pretty high on both axes. Now, again, these are self-reported results. There are some benchmarks that they have introduced. We'll need to wait for external validation, but overall, I'm actually pretty happy with what I'm seeing here because not only they shared a lot more technical details than any frontier lab, but they also openly acknowledge some of the work they have used as a foundation to build on top of. I definitely think that it's a very interesting release, especially being the first product out of Thinking Machines. And based on the people who are still there, I think it's a very strong team. And I would be looking out for their releases because I think they are going to play a very important role, especially they're not releasing an LLM. They are trying to completely change the paradigm of how we interact with these computer systems. Anyways, do let me know your thoughts. What do you think about this release? Have a look at the demos and tell me if you are impressed or not. I hope you found this video useful. Thanks for watching, and as always, see you in the next one.